Okay, we're live. So we have our description, and we're gonna share the screen. So that's the problem we're working on. And let's try to do something within 30 minutes. It's a good time goal. Check if a string can break another string. Given two strings with the same size, check if some permutation of string S can break some permutation of string S2. When A can break a string S can break string Y. Both sides M. If is alphabetical order, alphanumerically, for all I between A, B, C, X, Y, A is a permutation of so what meaning can break string if X is bigger or equal. Okay, so it's bigger or equal. And in this case, they're saying that X, Y, A is bigger than A, B, C, or equal. Can break two string ABC. Yeah, but they put A, in this case, A. They take the permutation of AYX. So that means A is the same. Y is bigger and X is bigger. So that means why we don't put A here, because A is smaller than B. Yeah, so we found the minimum. So basically, I need to draw here. I can't talk about it without drawing. But I mean, and then another case is A, B, E, and A, C, D. So if we have our alphabet A, B, C, D, E, F, G, H I J K L M N O N O P Q R S T U V W X Y Z. Oh, Z. So that's kind of our axis. And in this case, AXY was this 1, 1, or YX. Yeah, let's do YX. That makes sense. 1, 1. So that's string 1. But string 2 is the smaller string is 2. Is 2, and then it has C, C, and D. And that is 1, 1, 1. So what I'm trying to see is the geometry of this. I mean, or or how it looks like, what it looks like on graphic, the graphical representation of it. So that's the first example, but the second example, and the first one works. So these are equal and these are bigger than each of these. And by the way, we do need to put, yeah, one in like kind of above the other to show that. So that's kind of above that one, and that's kind of not above, that's kind of the same level. Now, the other example is also a CD. Oh, wait a second. That was ABC, but I mean, it doesn't change much. Yeah, the other one is ACD and ABE. Okay, so that will be A, that will be B, that will be E. So, I mean, A is fine, but here one is smaller, the other one is bigger. And I mean, the best thing we can do here is, yeah, do this 2 above 1, but the other one goes around. Is in reverse, so none of them can break the other string. I don't know why they say break, but and it feels like sorting could help here. And we have the length of n, the length of n, yeah, and the length is from 1, at least 1, until 10 to the power of 5. And they all consist of lowercase English letters. So it feels like, yeah, we sort them first. So in ascending order, so we kind of have that. And we take the, let's say, the smallest ones. Another approach would be to, because I mean, once we sort them, it's gonna make things easier. Yeah. To compare. But another idea would be to sort them in kind of one array, have them sorted in one array. But okay, let's say we have them sorted. How do we tell? So if they both of them start with that, with equal, that's fine. So we can continue with any. If one of them is on the smallest scale is higher than the other one, then we need to check. Yeah, so once we have that, because if they're all the same level, they can break each other. Okay, but once we get that difference, we need to check if that difference continues. So we disregard, then we will disregard the equal values. But those values that are bigger, that are different, we'll have this, that difference, and we'll need to make sure that it continues. If it's like positive or it's negative difference, that it continues to be the same. So an n log n solution would be like that. Yeah. Let's try that first. So we'll sort both slices. Sort this one. I wonder if I can do it like that. Slices. Golang slices sort. I wonder if I can. Yeah, I think I don't need to worry about it. I should just slices sort. Why I need to sort them out? Because otherwise it's just a total chaos. Now for I range S1, or doesn't matter. So now we have this thing. If the sign of the diff changes, that if S1I is so if it's not equal S2I, then we need to do that. Yeah, we need to check what's the difference. Once we found some difference, we'll know And we know that this difference cannot, if it changes the sign, not the value of the difference, but the sign of the difference from negative to positive, because what we'll do then, we'll do 2s to I, and we'll get the diff. So if that difference changes at some point, that's when we need to step in. But so once we find the first diff, we need to remember and then track if it ever changes or not. That's the thing, yeah. So I wonder how we should do that. So this diff, if this diff, this is a sleepy random LeetCode on a Fluke, so good exercise when you're not, when you're a little sleepy. But so what's the brute force solution for this sub problem? Okay, so the sub problem is we have a diff. And yeah, basically we need to get the sign of this diff. It's either bigger or smaller than 0. It's not 0. So if that one is bigger, if S1 is value is bigger, we can do it like that. Also, just compare which one is bigger. So we need to say that, let's say then, what they call them. As we go, is we have two parts here. This initial value of this comparison. Get the first comparison and then compare it with with all the other comparisons. That's kind of the thing. So if we can do if that and diff is 0, or I mean, we can do okay, if we have some difference, we can check if diff is 0. If it's the first one, then we just assign. If diff is 0, we record our sign. Okay, we'll say that, and we'll say the sign is let's say it's 1. Okay. Okay, so if they're different, but diff is still 0, we change the diff. We say, okay, diff is now that, and if diff is less than 0, then we say that sign is -1, else sign is 1. Or, oops, doesn't really matter, but I mean, sign is 1, and else, yeah, so if it's above, yeah, so now we have initialized it for the first time, but if the diff is not 0, then we need to check. So else diff is not 0. So the sign was something, either negative or positive. So we evaluate diff again, and then we check if diff is above 0. Yeah, if diff is positive, and the value is positive, and the sign was positive, we're fine. But if the sign changed, so if diff multiplied by sign, if that is bigger than 0, we're fine. But if that's smaller, so we have different opposite signs, then returns false. Otherwise, we just need to return true. I think it should work like that. Turn true. I think it should work. Sort slices sort is 1. Oh, yeah. So that we have strings incoming. So we want to first turn them into slices. So we're gonna have that. Let's slice. Well, slice 1 is let's turn them into slice of byte. Convert them as 1, and the same thing here. So slice 2 is a conversion into slice of byte, because I mean strings are read-only. So yeah, we have slice. I mean, it's not the best name. So once they're sorted, we can once they're sorted, we can convert them back. So we'll say that string one is now string of slice one, and string two is now string of slice two. So like that, yeah. Oh, yeah. So we're dealing with bytes. Can we actually do slice of int and slice of int instead of bytes? No. Cannot convert type of string into slice of int. Yeah, it has to be bytes. Well, we can just use all bytes. Then we'll do that diff variable diff of type byte is type byte. Okay, diff is type byte, but sign is type. Yeah, so in variable sign of type. Oh, byte is unsigned. Yeah, you can't. Is an unsigned uint 8-bit unsigned integer, which is a byte, uint 8. And I have 10. We're almost there. So the sign could be negative, yeah, but we can't use it for int, yeah. We can multiply diff and the sign can be, yeah, it will go diff, it will go negative. But we can't really use bytes in this case, byte value, because it's on the, well, in that case, the easier solution would be to just stay within like what is bigger. So 1 or 2, basically 1 or 2. Yeah. So we'll say that we'll not use the diff. We don't need the diff. We'll just remember what was bigger, 1 or 2. Like we'll say the big of type int is 0 initially, and if big is 0, so it's the first time, then we will just compare. We'll compare S1 and S2, and we'll say, so we know they're different, and we'll say if S1 is bigger, okay, so we know they're different, and this is the first time, so we remember, we say that big is 1. If the other one, then we'll say the big is 2, okay? If it's not the first time, we'll do our comparison again. And we will say, okay, if that is true, if it's bigger and if but big is 2, return false. And the other option is, yeah, if that is bigger and it's 1, also return false. Something like that. So it should be working now. Yay! Well, at least this test cases worked. The default. Let's do the. Yay! They all work. I wonder if we can. Yeah, I know the time complexity. I mean, we solved it. It's not linear, but it's a good solution. I think, yeah, within 32 minutes, we solved the medium level problem. Not bad, I would say. Where is our solution? That's our solution. Not bad. Let's see what other solutions were like. The sample code. Let me just check them. There is no editorial. So did anybody use sort? So I'm not seeing sorting here. Okay, they use a sequence. They use a bytes array. Can override. Okay, so there is some cool solution about. Obviously, it looks like it's about looking at the frequencies. Okay, so we take the A's, you count them, and we take the A's there and count them, or whatever the value is, but we decrease them. So then we'll get this. Then we also collect. So all the all the equal values will be gone from this frequency computation. So how many times? So we'll say like we have 2 B's, 2 C's, and 3 C's. Okay, I understand that. 2 D's, and if there are like 1 A in the other one in the first slice and 1 A in the second string, I mean, then they cancel each other. Okay, sum and old. Then we go over that frequency slice, and we get the sum of each value. Okay, if sum is 0, then we just continue. So we add the value to the sum. Yeah, if after adding it's 0, so we continue. So we go to the next value. But if it's not 0, so there was some value, then we multiply that with old. I don't know what old is. So sum by old. I mean, so yeah, I'm trying to understand the other solution, the which seems to be linear, I guess. Yeah, seems to be linear. But I mean, yeah, we did the. we did solve it within 32 minutes. Yeah, so I think for a sleepy LeetCode, that's good. And it's good runtime. Yeah, so then, yeah, what's the other solution? Yeah, the sum, okay, there is some value multiplied by old. And okay, so the old is like this prep. It looks like it's previous, which was 0 initially. And if it's less than 0, return false. Less than 0. And then we say that previous is our sum. So it's not less than 0, we just continue and we record, okay, let's say that sum is like 2. So, and old is 0, it's 0, we go on and we remember, okay, previous was 2. Okay, next time, but if sum, interesting, I wonder why. So, and where could we get a negative value here? Well, if we have 2 A's here and 3 A's there, yeah, that's where we'll get a negative frequency calculation. Okay, so what they're getting here, like any, okay, there's like positive numbers of A's, positive number of A's, like 2 A's, but then all of a sudden there is like, the next one comes with 3 B's. So sum plus, so we add this current value, this minus, so B's, I'm not 3, but minus 3, okay, negative 3 B's, and so sum is not 0, so we're here, but sum is negative now. So it's minus 3. And we know that that could come only if the second array had more B's than the first one, than the first array or the string. Interesting. I mean, it's a very short solution, but I don't clearly see the explanation here. So I might look at it more. I need to look more into it. But I think for a pretty sufficient, I guess it could be the solution that we gave could be a sufficient solution. Not perfect, but n log n is pretty n log n is pretty good. So yeah, so that's our random LeetCode on a Fluke, and we'll see you in the next stream. Thank you for watching.